Hello, welcome to another part. So this part is going to be about making more style variations. At the very beginning of this series, I talked about how there will be style variations. That's why I added the option in ChatGPT to ask for styles. So we have one, two, three, four. So we'll be quickly making three additional styles. So I already had style one, which I had here, and I will be improving on that. So I will basically copy this note three more times. I will probably delete most of what's inside of it, as I will just make my own or new setup. So let's start with style number two. Again, this heavily depends on like references and other things you have looked up to. So I will be making something that I thought would be interesting to do. I probably want to remove a lot of the parts here. I like the parts where I make like the here like the small stud at the top, at the bottom, like these things. Maybe I want to keep those, so we still can do that. But maybe for the ads sign itself, I maybe want to do an extrusion on that. So here, let's grab extrude, poly extrusion, grab it like so. And with that, we can just give it an actual 3D shape, or we can also do an inset here, make it either bigger. So maybe let's do minus, let's say, maybe not too much, like 0.6. So it's like a little bit bigger. So we make it a bit more bigger, and you'll see in a moment why as well. And we probably also want to disable the side here. So we will actually remove some of the geometry. We only want like the front facing primitive. And we want to do another extrusion and give this then actual thickness. So here, front extrude, maybe just a bit. Doesn't have to be that much. Maybe the same as the legs probably. So if you look at the side view, maybe give it indeed something that's around that size. We can also close the back, of course. We want to make it nicely into a closed shape, and we can merge these things together. So maybe delete this merge and make a new one. So here, merge these together like so. So we have a new plate. So I don't like that they are like off center. So again, if we want to align something, we are going to use the match size node. So that's very straightforward. Again, match size node, you can see that I've already used it a few times. It's just very useful. As you can see, again, I'm just aligning this shape. In theory, I don't need to align every single axis, only I think it's here, the Z axis. So in theory, I could say none to the other ones, because I only want to have that Z-axis alignment, so it nicely fits with the leg part here. That's something to just keep in mind. It's not always about aligning every axis. It's sometimes only about aligning certain axes. Then we can use the color system here as well, because this is my board that can have a color. If we want to assign a wooden material again on that. So here we have that board. Then for the actual like chalk sign board where we can write the names on, we want to change this shape here. So these were just a bunch of planes. I now want to do also an extrusion on that. So this could actually be removed, and we can extrude that. So here, poly extrude, grab it from the line, and we can give this then a thickness. So it's up to you how thick you want this to be, maybe something like this. We want to, you can enable the back. I don't think it's needed because we won't necessarily see that. And we probably again want to do some sort of like matching or making sure it's nicely fitting in the shape. So here, as you can see, it needs to be pushed forward. So we can do maybe match size here with that. And we can grab our board. And what we want to do with that is, again, only the z-axis probably, so none. So we're going to set this to z minus and to max. So now it's, as you can see, it's now sort of like on top that object. And that's basically done. So we now have these sitting on top. So we have a extrusion parameter to make this a bit thicker or thinner. So we just have like a different type or style. And then we also have the text, which in theory you can also use the same match feature. So we're going to grab the same nodes and just place the text in front of it like so. And then we have a different style, as you can see. That's style number 2. Let's go to style number 3. So style number 3 will be way different. That's why maybe I'm going to delete most of the nodes here. So maybe I can keep only the nodes that assign the materials like that and delete the other parts. We still have like 1, 2, 3 as input. The fourth one is not needed. Then I want to, from number 1, do like a small scaling. So it will basically, my board now will be like one big chalkboard to write on. We don't necessarily will have a wooden structure. I will scale this up a little bit because I will do a boolean. So we want to make a bit more room. So let's say scale is 1.2, something like that. Then we do an extrusion on that shape. So poly extrude. This again can be just a little bit, doesn't have to be that much. And we want to close that off, so it's an actual closed shape. Then from that, I want to like cut out the bottom part procedurally. There are a couple ways of doing that, because if the add board would scale up or down, we want to also have that cutout at the bottom scale with that. So I will extract with split primitives the bottom primitive. So here, if we go to y minus, we can get that bottom part. So if again, my setup would scale, that primitive scales, of course, with it. From here, we're going to maybe do a reverse of the primitive. So it's facing upwards instead of downwards. Then we can do some scaling. So transform, scale. We're working, everything is here actually, of course, in the world center. So I don't necessarily have to match the pivot points necessarily. So it should be fine. And I want to make the scale here a bit smaller, like so. Let's maybe do like 0.7 somewhere. So 0.7. And here in this axis, let's do maybe 2, make it a bit bigger. So I will also now move my shape a bit upwards, like so. So it's roughly in the center with this transform. So if we do an extrusion in a boolean, we are nicely have enough room to do a cutout. Then of course extrude this shape. So extrusion doesn't have to be that much, and we want to save out the would say the front group as primitive, and we want to close also the shape. Maybe we can move this shape a little bit downwards. Just again, if you do like a boolean operation, they usually like it when you have like a bit more room, so it works a bit better. Then we're going to do a transform, and we're going to scale the first primitive. So we saved out a group here called extrude front. So in this transform, we're going to say get extrude front, and we're going to scale that like so. So this will be my cutout. So this is the network done, and the final touch will here be putting in that boolean operation into our base polygon here, like so. This will be our sign. So we just made like a big cutout. So again, this will scale with the shape. So if I go back here, if I would scale this up or down, you can see roughly like it would scale with this. So it always like keeps some form of shape. There are again like many ways of doing this. This is like a quickly setup for it. So that is roughly my shape. Then this is, like I said, we don't necessarily have a wooden structure. So this will be my board material. So this will be fully my board. And then we still have the text. And in case here, I think number 3 was our text. So if I add text here back in, it is sometimes possible that the text is maybe larger and can collide with this shape. So I might want to do like a match sizing pass here as well. I'm going to try to calculate roughly like a sort of like space with some padding in case this shape would be sort of like subtract too much. So I want to calculate like an area where the text can always be displayed. I will use the shape that I used here for a cutout, and I will basically sort of like exaggerate that by scaling it up here in this direction, maybe like by 20 or so. So it has a lot of room. And then we're going to do the cut out the boolean here again with the base shape. So as you can see, we're now getting the area. So this is just basically the part without the like these lag parts sort of. And from that, we can calculate the area where it would be nice to have the text. So maybe we can do like a little scaling, and we probably want to set the pivot in the center. So I will say $sign dot CEX, and this is for the x-axis, and then here again, same but for the y-axis of CY. So center, again, center Z. And this will then get the center, and we can maybe scale this down to 0.9. So it's just like a little bit smaller. Then we can do the same thing that we often did, is just doing a matching pass. So match with the shape. So here match size. This is my reference. This is the object to match, and should be fine by default. Maybe we can do max here, so it's like in front of the shape, and we can always like manually force it to do an offset, so we can force it to be like a little bit up front. And this is then my text. Yeah, probably of course want to enable the scaling here as well. So like I mentioned, in case the ad board gets maybe smaller, we can also nicely scale that with it. So don't forget to enable the scale. And let's go to the last style here, style number 4. And this one will also be way different. What I would like to do with style number 4 is I'm going to delete again most of it except for the nodes here, the material nodes. So delete everything, delete the lines, and I'm going to put this on the side here for now. So from number 1, I basically want to get the wireframe and do like a sweep around that. So this one is going to be more like a metal construction instead of a wooden frame. So we will go for a convert line. So this will take your polygon and basically turn it into lines. So we are now don't have any polygon, but just line shapes. From here, we can do also a transform like so. And I want to rotate this, but I want to rotate this from the top part. So I will put my pivot point at the top of the primitive here, or the lines. And this is just, again, you can try to do like the match size node before and then do it that way. But you can also just calculate the bounding box with this function. So get bounding box, and then we're going to say bounding box from 0 means itself, and then we're going to say d y-axis called max. So we're going to get the highest y position, which is in this case again that top. So this will be the rotation amount of our piece, which is maybe just rounded up to 12. Then we can do a symmetry on this, so it's called lapse symmetry. I'm gonna rotate this in the other direction like so. And this is sort of like my metal construction. The only thing I need to do here is, let's try to use the a polywire with UV. So lapse polywire with UVs, put it in, and you should have something like so. We want to probably change the width to, let's say, 0.05. That's okay. And we want to then have the divisions maybe increase to 10, so it just has a little bit more geometry. So this will be my wireframe, and in the middle we have then the ad boards that will be hanged up based on the frame. So that's the base part. Now I like to calculate a sort of like just a simple plane where my text can be on, and I will use my third input here, so number 3. This was the text, and we can calculate the bounds from this. So this will be the required space in theory. So this is the required space to view my text, if I don't scale it, of course. This will be my new board shape. We probably want to do some minimum size requirements. So the board right now, it's probably, as you can see, not that thick. So we're going to say the minimum is 0.05. So you can see we're giving it a bit more shape. So this is like the minimum of the bounds. Then we can also include some padding ourselves. We're going to put this into 0.1, and also here 0.1 and 0.1. So ideally, this is sort of like the board shape that I want to add to my metal construction. So you can see it's like still a little bit too big. So I want to then solve that in a moment and combine everything. So first of all, let's add the text to that board. Maybe we can also give the board a certain color like I did before, just so Houdini, we can preview it better. So let's give it a darker color. From here, let's do again match size. So we want to match the text on the board. So reference text. Then we're going to need this to be in the maximum, as you can see. We probably want to do like a little offset so we don't have any Z fighting. So a little offset there. And we also want to probably have the text on both sides of this board. So we do a transform and do a 180 rotation. So like that, and then do merge. That should usually be fine. We can already ask this to be the text group. We're going to remove the line. Then we're going to merge this with the board, like so. You can see maybe if I look at from a point of view, we don't necessarily have this matched up nicely. So in theory, I can here match this better here, like so. So we have this board. So this is complete. So we have the board with the text. We can also add the group for the material here as well. So we know that. And the part that is still left is, like I mentioned, we need to like scale it properly into the wire metal frame. So maybe let's move this around here. We can do like already like try to like transform it and scale it. But again, we're gonna just probably use the match axis anyway. So what I will do is from our lines here, I think just going to use the first one. I'm going to calculate the bounds. So this will be giving us roughly how much room there is. And here we can, again, like either add and remove certain padding and features. I want to give this a bit more thickness. So let's say here in the size 0 to 2, just give it a bit more shape. Then for the padding, we actually want to remove from the padding. So I'm going to hold my middle mouse and I'm going to do one single tick in the negative direction. So point -1 here as well, point -1. So just one single tick basically. So it's like just a little bit smaller. Then we're going to do the matching size. So match size, and we're going to use bounds and the transform. Then we don't necessarily need to worry about the actual translation. It's more again about the scaling part. So by default, scale to fit should give you a good result. You have to again be careful with the padding as well. So if you set this to something super low, it won't necessarily work. You need to set it to like a 0.2 value, something like that. Then it should be good to go. So if you would merge this together and the board, they now like nicely align roughly. Like there is some like spacing between the shapes. So the only thing left is sort of like build like a metal chain or something, or a cord or a rope or something. So I will quickly talk a bit about that as well. What I will do is from here, I will make a blast node and get the top line. I will here select the top line myself, which usually should be something like 0 to 1. Maybe instead of the edge mode, I probably want to do primitive mode. So I'm gonna fill in 0, I think it was. So maybe you can preview I should probably preview the lines. It should be 1. So primitive number 1 is the one that we want to keep. So here, primitive 1, delete unselected. Then from there, scale this line in the x-axis. So scale like so. This will be, these 2 points will have the sort of like a chain to the point. I'm going to quickly do an add node. I will use this to here delete all the geometry except for the points. Then with these points, I'm going to maybe remove the lines here for a second. I want to do a ray cast, so I'm going to say ray cast, and we want to raycast to my board that is hanging down here. So raycast to that. And we want to do a direction from a vector. We're going to right click, delete all the values, and we're going to say -1. As you can see, now our points are here. So you can see that our points are hitting that shape, and this is basically the connection that I want to make. So I want to merge these points together here. So the original points with the hidden points, and I want to connect them with a line. There are a few ways of doing that. What I usually would do is I would place down a enumeration over here. And the enumeration will basically, if we set this to points, it will just keep track of the point number. So as you can see, we have 0 and 1, 0 and 1. So after our raycast is done, you can see that we have these numbers called 0, 1, 0, 1. So we need to connect 0 with 0 and 1 with 1. And that can be done with an add node again. So an add node is, you can remove geometry, but you can also create here new connections or new polygons. So we want to create a new polygon by group based on attribute, which in our case is again called index. So we'll basically group the points with a primitive that are the same value. And you can do a sweep, or you can also try to do like something special, like a chain or something. I'm going to just do a sweep. I'm going to do a round tube, make it a bit smaller, like so. And let's start merging things together now again to see how that works. I can still use that merge node. So here, like so. And we have now something like that. Maybe we can make it a bit smaller again. We can also use the points that we had here to copy a small shape on. So we have these points now. We can just simply do copy 2 points and copy like a box or something. Let's do something like that. So the box is a bit too large. So let's go to box and let's scale it down and maybe squeeze them like so. And let's merge that in here. So we have now sort of like these clamps for the board. So I'm going to grab my board over here. And now we can have this. And now that is sort of like done. So I have now this shape over here. So again, what I did is I extracted the top part. I raycast those points onto my board. And I connected the lines again with a line and a sweep node. Then you can, for example, copy paste like a clam shape or something like that. I just use the box so to keep it simple. And then you can have something like that where you have the feeling that at least it makes a little bit sense how it's constructed. But again, if you want to model some better things, feel free to do that. There is like some room to improve some of these things, but it will just look like these clamps are holding down the board. So it makes it a bit more believable. Then a lot of these parts are in theory called metal. So instead of the wood group here, I'm going to call this metal. So this will be like a more metallic frame. So metal frame. So those are now our styles. Now the only thing interesting to add is this setup that I made here. So this setup was to copy paste the board to the other side and make it something more like this. So style number 2 also benefits from the same setup, and also style number 3 will benefit from this setup. Style number 4 is a bit different as it has its own way of constructing that. So style 1, 2, and 3 needs the same logic. So there are many ways of how I can approach this, but I would like to show you a way with using a compile loop and the invoke system. So this will be wrapped up in a loop, and we're going to reference that setup. So let me here put it on the side. So we're going to create a compile loop. So compile block here. And in this block, we are going to wrap up what we created here. So make this big enough to put in our setup like this. And in theory, you can always like give these inputs names. So input number 1, for example. And with that, this is now sort of like its own system roughly. It depends. There are many ways of like using compile loops. And in this case, we're going to use it with an invoke sub, so invoke node. So this invoke node, I'm going to give this a color here quickly. This invoke will reference this setup. So we don't have to make like a special tool or HTA from this. This invoke will reference the data over here. So it's important to know and to understand. So to quickly get this working, there's a few things to do. So this invoke itself is not referencing to anything. You can see it needs all empty spaces. So we need to say which compile block. So we're going to reference or drag and drop the end of our loop. And we also can here specify input namings. So here I called my inputs just input 1. I'm going to do that same here as well. So input 1. And now I will plug in my shape. And if everything works correctly, you should see that logic being applied to your shape or geometry. So I want to copy paste this invoke here as well. So this works and this works as well. So this is a way to almost like, invoke or instance sort of like this network into other networks without having to make an HTA, because to me, it's not that interesting to make an HTA from this. Like, it's so specific to these things that it's not that interesting to have sitting around. And that's basically where this part will end. So the only thing that's left to do is we can make a switch node, and then we have here all the different options to switch to. So in a later stage, I will make like a digital asset, and then we can switch from these different boards. So as you can see, it's up to you to make like more styles, more variations. So this is basically open-ended to add more ideas to create interesting boards. Like if you want to create something that, for example, hangs on the wall or on the ceiling, this is mainly to stand up on the ground, but you can vary it on that as well. So that was it for this video. Hope to see you in the next one.